In this video, we're going to talk about symmetry of functions. Now, the graphs of certain functions have symmetry properties that help us to understand the function and the shape of its graph. So we are going to consider two functions here and look at its graph and its shapes, right? So let's say I have these two functions here. F of x should be equal to x exponent 4 minus 2x squared minus 3, right? So let's say I have this function. Let's take another function here. So let's say I have function which is f of x should be equal to x cubed minus 4x, right? Now let's look at these two functions here and look at its graphs, right? So when we consider these functions, right, if we take the part of the curve that lies to the right of the y-axis. So here I'm just going to talk about this function first with the graph of, consider this graph right here. When we consider this graph, which is f of x should be equal to x cubed minus 4x right here. Now, which shows its graph right there, right? So if you take this graph and rotate it 180 degrees about the origin, the new graph will look exactly the same. So in this case, what we say is that the function has a symmetry about the origin, right? So that's what we showed right here. And first graph right here. When we look at the first graph, if a function f of x, or if a function f is a symmetry about the origin, then whenever the point x comma y is on the graph, the point negative x comma negative y is also on the graph. So what we mean by this is that if we have f of negative x, this one should also be equal to negative f of x. Now if a function has this property right here, then we say the f or the function is an odd function which has a symmetry around or about the origin. For example, if you have f of x which is equal to s cubed, this is an odd function. Why? Because f of negative x will be equal to negative x cubed, which will be equal to negative f of x. That's why we said this one is an odd function, right? So how do we define all this? Let's just summarize this one right here. So what we are trying to say right here is that if f of x is equal to f of negative x for all x in the domain of the function, then f is an even function. So an even function has a symmetry around the y-axis, right? Now if so, this is an even function. Now if f of negative x is equal to negative f of x for all x in the domain of the function, then f is an odd function. So this is an odd function. That's how we can define it. So an odd function has a symmetry around the origin. So now let's look at some examples right here. So we are going to determine whether each of the following functions I'm going to provide here is an odd, even, or neither, right? So let's take the first one. So let's say the first one I have f of x should be equal to negative 5x cubed plus 7x squared minus 2. What can you say about this? What can you say about this? Now let's determine it. Let's try to determine it and see. Now, so here we can see that. So let's try to do it. So f of negative x, right? Let's do it that and see. So we are going to put negative right there. So we have negative 5 negative x exponent 4 plus 7 then negative x squared minus 2. Now when we do this, we should get negative 5 s exponent 4 plus 7x squared minus 2, which is equal to the f of x that we just did here, right? So with this, we can see that this is an odd function. So an odd function is when f of x is equal to f of negative x. So you can just put it that way and try to determine it, right? We can put it out. So when, let's say when we did it and we didn't get the same thing, then from there we can just go ahead and see that this one is an odd function or neither. So let's try another one and see. So b, let's say we have f of x, which is equal to 2x 5 minus 4x plus 5, right? Let's look at this one. So first, let's determine if it is an even function. So even function is when f of x is equal to f of negative x, right? So with this, we'll put negative x in wherever we see x, right? So let's look at it and see. So with this, we'll get 2 multiplying x minus x exponent 5 minus 4 minus x, then plus 5. Now when we do it, we should get negative 2x exponent 5 plus 4x minus 5. Now we can see that here when we did it, we got f of x is equal to negative f of x. Now with this, what we call this property, this one is an odd function. So with this, we just say this function is an odd function, right? It's an odd function. It's an odd function. So let's look at something here. No, there's something wrong here. Let's look at it again. There's something wrong here. So when we did it, we got negative 2x exponent 5 plus 4x minus 5. That's what we got, right? So everything here has changed. So now that we can see that f of negative x is not equal to f of x, right? So furthermore, noting that negative f of x, right? Let's do it if it's, so we just tested and it's not an even function. So let's test if it's an odd function. So odd function is when negative f of x is equal to f of x, right here. So let's do that. So with this, we will get negative 2x 5 plus 4x minus 5. So we can see that f of negative x, so negative is right here, is not equal to negative f of x. Therefore, the function is neither odd or even. So neither odd, neither, so let me just cancel. So neither odd or even. I think I just corrected it right here, so you can see the correction what we did here. Now let's look at the last example so that we can get to understand it very well. So let's look at this one. So f of x, which is equal to 3x on x squared plus 1, right? So with this, let's test even function first. So even function is when f of negative x is equal to f of x, right? So with this one, we'll get 3, then negative x on to bracket, small bracket, big bracket, and small bracket. So x squared, right? Then plus 1. So when we do this, we should get negative 3x on x squared plus 1, right? And so this one is what we got, right? So when we do it, when we do it, we should get into bracket, big bracket, then x squared, so x 3x on x squared plus 1, right? So with this one, you can see that the negative is outside of the main function, right? So with this one is equal to negative f of x. So therefore, this function right here is an odd function. It's an odd function, right? So that is that. Now let's look at the last one, right? In this video, we're going to talk about symmetry of functions. So we are going to consider two functions here and use to describe its graphs, right? So the graphs of certain functions have symmetry properties that help us to understand the function and the shape of its graphs. So for example, let's consider these two functions here. F of x should be equal to x exponent 4 minus 2x squared minus 3 here. Now, in this graph or this function, if we take the part of the curve that lies to the right of the y-axis and flip it over the y-axis, this graph, it lays exactly on top of the curve that's exactly on top of the curve to the left of the y-axis. So in this case, we say the function has a symmetry about the y-axis. So this function right here, or this graph right here, it has a symmetry about the y-axis. So on the other hand, when we one that I just showed right there. Now, if you are given the graph of a function, it is very easy, very easy and easy to see whether the graph has one of these symmetry properties. But without a graph, how can we determine algebraically whether a function has a symmetry or not, right? So when we look at the graphs that I just showed right here, now we can see that since f is a symmetry about the y-axis, this one right here, since f is a symmetry about the y-axis, if the point x comma y, right, is on the graph, then the point negative xy is on the graph, if you understand that. So what do we mean by this? What we mean by this is, if you have f of negative x, this f of negative x can also be equal to f of x. So if a function f has this property, we say f is an even function. We say f is an even function which has a symmetry about the x-axis. For example, if you have f of x should be equal to x squared, which is even function. This function is an even function. How can we determine that? Now, this is because f of negative x will be equal to negative x squared, which will be equal to x squared, which will be equal to f of x. Very simple to do. Now, in contrast, when we look at let's look at the last one right here. Now, with this last one, we one of the symmetric function that arises frequently is the absolute value function, which is written as the absolute value of x, right, which is written in this form. So with this one, the absolute value function is defined as f of x should be equal to x comma x less than 0, then s comma x greater than or equal to 0. So some students describe this function by stating that it makes everything positive, right? That's how some students state it. So by definition of the absolute function, we see that if x less than 0, then the absolute value of x should be equal to negative x greater than 0, right? And if x is greater than 0, then the absolute value of x should be equal to x, which is positive, greater than 0. But however, you have to know this: for x equal to 0, then the absolute value of x should be equal to 0. So therefore, it is more accurate to say that for all non-zero input, the output is positive. So for but if x is equal to 0, the output is equal to 0, right? So we can conclude that the range of the absolute value of the function is y is such that y is greater than or equal to 0, right? We can state the range like that. So when you look at this diagram right here, so this one shows the absolute value function, which is symmetric around the y-axis, and therefore it's an even function, right? It's an even function. So absolute functions are even functions. You have to note that as well. And this is the end of this video. Thank you for watching, and I'll see you in my next video.